Hi, welcome back. In this video, I want to explain the basic definitions of electronic devices. So first of all, we have to discuss what is electronics. What is electronics and what is electronic device, right? And which type of materials are used in this and some standard values. First of all, we go to the definition of electronics. Generally, the electronics we can write like this. It is the combination of electron and mechanics. Electron and mechanics. So mechanics word is used to movable, right? So mechanic words is used to move the representation. So movable elements generally we can call it as a mechanical representation, right? So electron movement. Simple definition is electron plus mechanics. So we have to move the electron from one place to another place. That is explained by electronics. So the standard definition explains it is the field of science and engineering which deals with the motion of electrons. It is a field of science and engineering which deals with the motion of the electrons. So simple definition, electron plus mechanics is called electronics. Electron device. Electronic device. Electronic device, this definition explains the devices which are made up of semiconductors. Examples: diodes, transistors, ICs, integrated circuits. Electronic devices, the devices which are made up of semiconductors which are used for controlling of flow of electrons or manipulating of flow of electrons. So examples are diodes, transistors and integrated circuits. IC is nothing but integrated circuits. In this subject completely I will explain the diodes part, right? Transistor purpose I will separate the course is there, that is completely comes under bipolar junction transistor. So in this course we have to discuss about the diodes. So this is the simple definition of the electronic device. And similarly, another parameter we are using in this subject, that is electric field intensity. Electric field intensity, which is denoted by E, capital E. So electric field intensity, this is defined as a force, the force acting on unit positive charge. So we can write force by charge. Force units are newtons and charge units are coulombs. So electronic field or electric field intensity is units are newtons per coulombs. And one more definition also we can write, it is the ratio of voltage to the length. So the length applied to the particular conductor or any material and voltage applied to that material. So the field intensity of the material depends on the voltage applied for that material. So we can write it's a ratio of voltage to the length. And another units also we can write here volt per meter. Volt per meter. So we can write like this now. Units of electric field intensity are volt per meter or newtons per coulombs. This is also one of the standard basic definition, right? One of the standard parameter used in electronic subject. And now I will explain the standard values. Standard values are used, these are the constant values, right? So just now I wrote here one word, electron. Electron means here we have to represent like this charge. Charge is denoted as Q. So I'm writing in terms of Q like this. It is a property of the conductor. Charge is the property of the conductor. This charge is two types. One is positive charge and negative charge. So charge is a property of conductor. This is generally available in two types. One is called positive charge and another is called negative charge. So we can write like this, charge value is plus or minus 1.602 into 10 to the power of minus 19 coulombs. This is the standard value, constant value, predefined value. So the charge value is 1.602 into 10 to the power of minus 19 coulombs. And the mass of the charge is an electron or a hole. So generally it has two types here, positive charge and negative charge. Positive charge is also called as hole and negative charge is also called as electron. Okay, so now onwards we are using these two words. Just try to remember, one is hole and another is electron. Right, the charge of the hole is positive and the charge of the electron is negative. The value is same. That's why I wrote here plus or minus 1.602 into 10 to the power of minus 19 coulombs. And the mass of the electron or mass of the hole is 9.1 into 10 to the power of minus 31 kgs. So this is defined in terms of kgs, right? So these two are the standard values of electron or hole. Simple representation we can write like this: charge, right? Charge is two types, positive charge and negative charge. Every charge has internally some field. Field is nothing but the force of combination of lines. Field is nothing but the force of combination of lines, and the positive charge field force of lines consists of outgoing lines. This line should be like this. The force of lines are always acts as outgoing lines towards the infinity side. So the direction of the positive charge lines are 0 to infinity direction, and similarly negative charge. Negative charge has force of lines. Those force of lines are acts as incoming lines. These lines are defined from the infinity to 0. So this combination of force of lines is called field. So every charge has internally some field. The negative charge consists incoming force of lines field, and positive charge consists outgoing lines of field. From these lines, coulombs defined. Like charges are repulse each other, unlike charges are attracts each other. Like if suppose I am taking one positive charge located here, another positive charge is located here. The force of lines of this positive charge, first positive charge consists of outgoing lines, and similarly the force of lines of the second charge consists outgoing lines. Now both the charges has outgoing lines, then the both are repulse each other, right? This statement is explained by Coulomb's. So Coulomb's law states that like charges are repulse each other and unlike charges are attracts each other. One charge I am taking as a positive, another charge is negative. This charge requires incoming lines. This charge field is defined like this, and the positive charge field should be outgoing lines. Now these two attracts each other. So like charges are repulse each other and unlike charges are attracts each other. That is explained by Coulomb's, and these laws are also called as Coulomb's laws. And this analysis is explained by the internal field. So field is nothing but force of combination of lines. And similarly, we have to discuss some other standard constant values, right? So from this, one of the standard constant value is Boltzmann constant. So please, Boltzmann constant value 8.62 into 10 to the power of minus 5 electrovolt per Kelvin. And similarly, we have to discuss some other constant values. So please take this. I will explain those constant values in next video.